And last time when we solved the exercise 5 of part B on the page 513, we have such a step. We add these two fractions, 1 over 1 plus the cosine of x and 1 over 1 minus cosine of x. And some guys have trouble with this sum of these two fractions. So actually, you first reduce them to the common denominator, right? The first one is the 1 minus the cosine of x divided by 1 plus the cosine of x times 1 minus the cosine of x. So if you cancel this to 1 minus the cosine x, just go back to this original fraction, right? And then for the second fraction, we multiply both the numerator and denominator by 1 plus cosine of x. Then the denominator becomes 1 plus cosine of x times the 1 minus the cosine of x. Now, these two fractions have the same denominator, and then we can add the numerators and keep the common denominator, right? So we keep the common denominator, so that is the 1 plus cosine of x times the 1 minus the cosine of x. Then we add these two numerators, so you have the 1 minus the cosine x plus 1 plus cosine x, right? So now this negative cosine x and this cosine x cancel, so you have the 1 plus 1, 2. So you get the 2 over this 1 plus cosine x times 1 minus cosine x, right? And for this denominator, we can use the formula of the product of the sum and difference of two terms, right? You have the a plus b times a minus b equal to a squared, minus b squared, right? And then now the a here is the 1, and b here is cosine x. So you have the a plus b times a minus b. Then you get the a squared minus b squared. So that is a 1 squared minus cosine squared x, right? And that is the 1 minus the cosine squared x. And we know by the fundamental identity, this is equal to sine squared x, right? Because sine squared x plus cosine squared x is equal to 1. Okay. And then from here, you got 2 over sine squared x. And then you used one of the reciprocal identities. So 1 over sine x is equal to cosecant x, right? So this one is equal to 2 times cosecant squared x. And when we use the fundamental principle, fundamental identity, and solve this for sine x, we have the sine x equal to plus minus the square root of 1 minus the cosine squared x. Some guy asked me how to determine the sign of this square root. It depends on the position of this angle x. If this x is in the first or the second quadrant, we know sine x is positive. Then you take the positive sign. If this x is in the third or the fourth quadrant, then sine x is negative. Then you take the negative sign. And some guy asked me one question on the page 517 from 88. So how to simplify this? And when you first fact this numerator, okay, fact out the sine square, you know, these two terms, have the common factor sine square x, right? Factor out this sine square x, and inside you have the sine square x minus 1, and divided by secant x, and secant x is the 1 over the cosine x. Now tell me, what is the sine square x minus 1? Cosine square x, or the negative cosine square x, right? You see, from here, from the fundamental identity, if you have the sine square x plus the cosine square x equal to 1, you move this 1 to the left side and move the cosine square x to the right side, you get the sine square minus 1 equal to the cosine, negative cosine square, right? So this guy is the negative cosine square. And then you have the sine square x times cosine square x divided by 1 minus cosine x. And then you flip this cosine x to the top, then finally you get a negative. Okay, and let's bring this negative sign to the front. Sine square x and then times cosine cubed x. So actually, we will do more problems of this type on how to simplify the expressions involving trigonometric functions. Another question is about the inverse trigonometric function value. For example, if we have the cosine x equal to negative square root of 5 over 4, then we can take the inverse cosine of both sides. We get x equal to arc cosine of the negative root of 5 over 4, right? And this is approximately equal to 2.164. And don't confuse this inverse arc, okay, this inverse cosine value with this negative root of 5 over 4. This guy is your input, this guy is your output, okay? This is totally different from this negative root of 5 over 4. Some guys, okay, I computed this value, I found this value is different from this guy. Certainly, it should be different from this guy, because this is the inverse cosine of the negative root of 5 over 4 is not negative root of 5 over 4. Now let's go to the page 517 and let's look at the problem 56. And let's continue to talk about the odd and the even function. We have f of x equal to x times cosine x, okay? And we need to determine whether this function is odd or even function or neither. So first, let's get the f of the negative x. So just replace x by negative x. And we know cosine is an even function, right? So that means cosine of the negative x is equal to cosine x. So from here, we get negative x times cosine x. And this is just equal to negative f of x, right? So you get the negative f of x. So that means f of the negative x equal to negative f of x. And this implies f of x is an odd function. All right? Okay. And sometimes we may have some equation which may not be an identity But how do we know this equation is not an identity? So we need to find some way to prove this equation is not an identity. We know identity is an equation which is satisfied by all numbers for which the both sides are well defined. So if you can find some number for which the both sides are well defined, and this number does not satisfy this equation, then this equation is not an identity.